Hi guys, and welcome to part 2 of the Sunrise Simulator Alarm Clock project. So in this part I'm going to go over the circuitry. I'm going to build the circuitry, do some programming and stuff. But first off, I'll go ahead and take a look at what I have here, and I'll probably have to modify this. So, as I showed before in part 1, I have this sort of dual gang switch thing, which actually has two separate switches inside of this one switch housing, if you will. I thought that was kind of neat, so I decided to use it on this. I have one switch that controls the lights that are underneath here, and that other one controls the lights that light up the room. But anyway, I want to look and see how this is wired on the bottom. So, first off, I got 12 volts coming in through here. Just got that little adapter that they gave me with the power supplies hooked into that, and then that goes into the switches here. Looks like the positive of that just goes to the center terminal. That switch, let's see here. There we go. Can see it a little bit better with the positive terminal, and then that just jumped across the switch. All the grounds are hooked together here. Looks like I got 4 wires going into that. And then I've got the positive lines for the lights running into these 2 contacts on the switch. So, anyway, I do have 2 lighting wires coming out of there. Should only really need 1, but I guess it's set up and it works, so I'm not going to change it. And then this other little wire goes to the ones that are up here. But anyway, the little 3D printed box may actually have to be ripped apart. I don't know if I can actually push this thing back out of here. No, well, maybe I can. But anyway, I'll probably have to change this up a little bit, because I do still want to be able to use these switches to turn the lights on and off manually, but I also want to have the circuitry be able to control the alarm clock, or not control the alarm clock, but be able to turn the lights on when the alarm goes off. So anyway, I'm probably gonna have to pull this out of here. I'm thinking I'll probably have to turn the grounds to the light on and off instead of the positive voltage rail, just because I want to use a in-channel MOSFET in order to switch those on and off with the microcontroller. So anyway, I have kind of a plan on how I want to do this. We'll see how it works. That switch actually did just push right out of that little housing, so that's alright. I'm gonna have to desolder all this to get the housing off anyway, but anyway, this will have to be messed with a little bit. I'm gonna rig in my circuit, which is currently set up on a breadboard, but I'm gonna get that stuck in here, and we'll see if we can get it to actually work here in a second. Alright, so I got the switch desoldered here. I don't have any lighting down here anymore, so I'm having to use the light that's on my camera. At least I have one. But anyway, should be able to get this little casing thing out, and we'll be able to rig in our little test circuit. We'll see if we can get that to work. Alright, so we go ahead and test this out here, and we'll see if this works at all. Just a quick little test. Alright, so everything's hooked up here. If I turn the switch on right now, nothing should happen, but it should arm the system here. So let's see here. Take a look at the lights up here. Yep, those are still off. So now if I come over here and turn this on so that that backlight comes on, these should start turning on, and look at that there. And if I turn this back off, because of course as soon as I hit the snooze button, that backlight's going to shut off again. They should continue to get brighter very slowly. So anyhow, you can kind of already see there's a bluish purple glow going around here. And also the lights behind the headboard here. Kind of messy right now, tearing everything apart, but and we should also have lights up here. You can kind of see how that those lights are stuck onto that little ledge there. But It's slowly getting brighter. You see I'm using this little lithium-ion battery pack that I built in a previous series of videos to power my soldering iron here when I need that. But anyway, seems like it's working fairly well, so I'll go ahead and bring this circuit back over to the bench and I will explain what I have on here. There's one more test here. If I shut this off, the light should go off with it. Yep, there we go. Alright, so I'll go ahead and see if I can explain what I have here. Well, first off, we'll start here. This is the 12 volt input coming from our little power adapter. I think it's like a 2 amp power adapter, so there's plenty to spare running those little LEDs. But anyhow, the negative side of that just goes into the ground rail here. The positive side goes into the voltage input of a LM7805 voltage regulator. And then the output of that comes back around to this rail over here and powers all the 5 volt stuff. Now, I originally wanted to use the 5 volt rail from the alarm clock, but since that rail is also used to power the USB port on the back of it for charging things, that doesn't work out very well because the voltage swings around a lot, and if it swings around a lot like that, I can't get a very accurate reference for when that backlight actually turns on. As you saw before, there's not that much of a difference in the voltage from when that's off to when it turns on. So anyway, I need a somewhat accurate voltage reference for this AT-Tiny to be able to pick that up. So anyway, I've got the decoupling caps on that too. It turns out I actually needed to put another capacitor across the chip, straight across the pins on the chip, or as close as I could get to it, because it was resetting when I tried to actually get this to work before. But anyway, that's just the little AT-Tiny chip. AT-Tiny 85 in my case. It worked just as well with a 45. The only real modification that I've made with this chip versus any other one is that I've put the 8 megahertz bootloader on it, so it actually the PWM pins are faster. I think usually these things have a 1 megahertz internal clock on them, and they only get like 60 hertz PWM frequency. So if you bump that up to the 8 megahertz clock, you get about 500 hertz PWM frequency. So it's good enough for what we need it to do at 500 hertz. But there's a few pins here. That blue wire is what goes to the backlight on the alarm clock, and that goes out to this. It's actually a 2S LiPo balance connector. But anyway, the other wire is that yellow wire. That goes through a switch. The other side of the switch is connected to ground. And then the power wires on the chip there, that's pretty self-explanatory with those two. The yellow wire jumps over to this logic level MOSFET. And then that is switching the ground on and off here. And then I think this goes gate drain source. So the source being the ground here, which would be from the 12 volts. Then that goes into the source of the MOSFET, and then the drain of the MOSFET just went over to here, and then I had the ground on the LEDs connected to this. And then let's see here, that's just a 10K pull down resistor for the gate pin. And that's about it really on this circuit board. So it's pretty simple. There's not a whole lot to it. But I do think I still have an idea for using this 5 volt pin that I have coming from here. And I kind of want to put in something to the point where I can still turn those lights on if there's a power outage. And if I did that, I could also keep the alarm clock on, since I have the 5 volts coming in from that too. But that's probably for a different day, a different project. So anyway, that's the little circuit board setup. Go ahead and take a look at the code now. Alright, so here's my code. Keep in mind, usually with all my code, there's probably a better way to do this, but I mean, this works. But anyway, starting at the top here, integer PWM. This is the 0 to 255 integer that actually gets written to the output pin. That output pin being this one, which is named just LED is what I called it, and that's on pin 0 of the ATtiny, which is one of the PWM pins on it. If you wanted to, you could use an Arduino Uno with this, or like an Arduino Pro Mini or something like that. Just change the pin numbers around. It should work fine. I like using these little ATtiny chips because A, they're small, really easy to fit into stuff, and B, they're cheap. So they work really well on these little projects that only need like, I think this has 3 pins is all that it uses. But anyway, value, this is for the analog value. That's what you get set to. Sunrise is the kind of flag pin for if it should be activated or not. Or, well, it's not a pin, it's just an integer. But switch pin, that's the pin number 1 is what the switch is hooked up to. And then switch state is the state of this pin. So anyway, that's pretty simple. So in the void setup, just 2 lines of code in here. Pin mode LED is set to an output, and then pin mode switch pin is set up to an input pull-up. And that input pull-up puts a pull-up resistor, or it enables an internal pull-up resistor inside of that chip, which I didn't actually think it would work on the ATtiny, but it does. So that way there I don't have to put an external pull-up resistor on it, and it works fairly well. But anyway, it's just a nice little trick there. If you are using an input, just a simple digital input with a switch, you can do that instead of putting an external pull-up or pull-down resistor. You just use that. So that works fairly well. So first thing we do in the void loop is we check to see if that switch is turned on. And 0 is on and 1 is off in this case, since I'm using it as a pull-up, which will keep it at 1 when it's off and then 0 when it's on. So anyway, if switch state equals 0, so if it's on, and we're going to check to see if the alarm has been set off yet. If it's already been set off, it's going to skip this part, but if it hasn't been, we're going to check, or we're going to set val to the analog read of pin A1. Obviously A1 is one of our analog pins on the ATtiny, but we're just checking to see if that's greater than 530. Now, I don't know what the exact number is when it trips, and or what the exact number is when that backlight on that LCD screen turns on, but 530 seems to be about the right point where it stays off when the LCD is dim and it turns on when the LCD gets brighter. So that works just fine. And if it does, sunrise is going to equal 1. And now we are still inside of this if the switch is turned on and sunrise is equal to 1. And if the PWM value is less than 256, so if it's 255, which would be completely turned on. But anyway, we just do analog write to the pin LED, and then PWM is the value. And then we do PWM++, which will add 1 to that PWM every time it goes around. And then you'll notice I do have a very specific delay here. It's 2018 milliseconds, plus there's another 100 milliseconds down here. And this works out to giving you about 9 minutes from the time that this starts to the time that the sun has risen, if you will. And the reason why I went with 9 minutes for this is because that is the, well, from what I've seen, it's the standard time that these alarms let you snooze. So the idea being, as soon as the alarm goes off, it starts to brighten up, and then by the next time the alarm goes off, it's fully on. But anyway, the last thing, if switch state equals 1, which would be the switch turned off, it resets PWM to 0, and then it resets the sunrise flag to 0, and then it writes the analog write LED to PWM again, just to set the, well, basically just to turn the LEDs off. And then you just have that 100 millisecond delay that I already pointed out. So anyway, that's it for the code. So the last couple things they need to do with this are
actually solder it onto a circuit board, and then I'm going to 3D print a little case for this little enclosure. But anyhow, I'll go ahead and start working on soldering this board together.
And it is also worth mentioning that I'm going to have to put a couple of diodes on this in order to keep those two separate light channels separate from each other so they don't end up just turning on, but that should be easy enough to add in. So anyway, I'll go ahead and get this thing stuck onto a circuit board. Alright, so here's the finished circuit. It took about 45 minutes to complete in total. But anyway, you got the voltage regulator on this side, the MOSFET over here, and the chip in the middle. So I took a couple parts out of this that I didn't need anymore. One was that capacitor that I had going straight across the power pins of the chip. I didn't need that anymore because the main 5-volt filter cap is a lot closer to the chip now, so I don't have to worry about that 6 inches of wire, so that was between them before, so voltage doesn't drop out and the chip doesn't reset, so that's pretty nice. I also didn't bother putting in that 10K pull down resistor on the MOSFET because this chip should always be on anytime this is plugged in, and if the chip is on, then I shouldn't have to worry about this pin floating high. The chip will pull it low. Actively pull it low. So anyway, other than that, this wire will go to the ground on the lights, and these are the power input wires, and that light goes out, or sorry, this connector goes to the alarm clock. So Anyway, I'll give you a closer look here on what pins go to where. The backlight, or you could add some more circuitry to this and use the speakers too, as this. But the backlight for that alarm clock gets hooked into this. What would that be? Pin 7, I think. On the chip there, the switch pin gets hooked up to pin 6, and then the gate of the MOSFET gets hooked up to that very last pin on here, which is pin 5. So other than that, voltage regulator is pretty simple. I just got the 12 volts coming in, ground on that. This red wire here is the positive coming from the alarm clock. That doesn't actually get hooked into anything, and that's there in case it gets used for some future project, but for now I don't need that for anything. So last thing to do is test this and see if it still works. Alright, so I've got the circuit stuck in here, plugged into the alarm clock, and the wires going into the lights are all hooked up here. So the way this should work is if I turn the alarm clock on at this point, that switch is shut off, so nothing will happen. And you'll see, basically I'm just simulating the alarm going off by getting that backlight to get a little bit brighter. But anyway, if we turn this on, and we turn this on, these lights should start to kick on there, so that's working. And this shouldn't have to stay on. It should continue to ramp the brightness up even without the alarm clock turned on, so it looks like it's doing that just fine. Anyway, the last thing I need to do is just go ahead and let this thing ramp all the way up and make sure there's no issues with it resetting or something like that. Alright, so it looks like it hit max brightness without any issues. I did notice, I just did some measurements on this here. I've got about 11.75 volts getting out to the lights here, and I've got about 12 volts coming in. So I am losing about 1/4 of a volt in the MOSFET here. And this is a logic level MOSFET, so it should be fine with a gate voltage of 5 volts. It's a little bit above room temperature. It's definitely not, I wouldn't even classify that as warm, but both of our little TO220 packages are just slightly above room temperature, so I'm not going to worry about that too much. I'm not losing enough voltage to really worry about it. But anyway, the lights did come all the way on, full brightness, as well as ones up there. So it's kind of hard to see because the sun's coming right in that window. But anyway, the last thing to do here is just turn this off, make sure that it does actually turn off, and it does. So anyway, that's about it for part 2, guys. The next part I will print, or 3D print, a little enclosure for this, and that will be the end of this project. So that's it for now, guys. Bye.